Let's talk about sector area and arc length of circles. The sector of a circle is like a piece of pie. It's the area of a specific region bounded by two radii of the circle and their intercepted arc. So when I say a piece of pie, it's how much of the pie are you taking out? It's that sector of the circle. Notice how you find it. You take the area of the circle and you multiply by the fraction of the degrees of the measure of the arc. Arc length is finding a part of the circumference. The arc length is the distance along an arc measured in linear units. So we have the measure of the arc, which is in degrees, but we can also find the arc length, which, as I said before, is a part of the distance of the circumference. So to find the arc length, we take the circumference and multiply by the fraction of the circle it is. Let's look at an example. We're going to find the area of the sector. Then we're going to find the length of arc JH. We're going to leave our answers in terms of pi. So in order to find the area of the sector, remember I have to start with the area of the circle and multiply by the fraction of the degrees of the circle. Well, if you remember, if we know the central angle is 131 degrees, we know that the arc is also 131 degrees. Central angle, same as the arc. We know that our radius is 12 meters, so we just substitute in our numbers. I'm going to leave 131 over 360 because we're leaving our answer in terms of pi, so we want that exact answer. So all we have left to do is to multiply 144 and the fraction, and we get 262 pi over, over 5. And our units would be meters squared. Since we are still with area, the units are still squared. Let's look at the arc length. The arc length, remember, is a part of the circumference, so we take the circumference times the fraction of the arc measure. Our radius is still 12 meters, and we're still using 131 over 360. So now when we multiply 24 times our fraction, we get that the arc length is 131 pi over 15 meters. And because circumference is just in that unit, then the arc length is also in just with the unit. Notice I have pi in the numerator of both answers. If it said to round to the nearest tenth, hundredth, or whatever, all you'd have to do is type in 262 pi divided by 5, and that would give you your decimal approximation. Take a look at this one. Now I want you to find the area of the sector and the length of arc AC. Leave your answer in terms of pi. Remember to separate the sector area and arc length, write the equation down the formula, and plug in the numbers. This one will be due in class. Let's take a look at a scenario. Say we have a windshield wiper blade that's 18 inches long. In terms of pi, what is the area covered by the blade as it rotates through an angle of 122 degrees? Car manufacturers need to know this information so they know how to get the optimum area of the windshield covered for when it rains, for safety of the driver. So if we notice, we're wanting to know what is the area covered. So that should tell you that you're wanting to find the arc length. Find the sector area. So we're going to find the sector area, which means we need the area of the circle with a radius of 18 inches long times the fraction of the measure of the arc it's using. So when we substitute in our radius and the angle measure, multiply these two, we get that it covers an area of 449 pi over 5 inches squared. Remember, we had to go back and look at what was the question asking for. Was it asking for the area of the sector, or was it asking for a distance or a length that it's going to cover? Take a look at this one. The gear of a grandfather clock has a radius of 3 inches. In terms of pi, what distance does the gear cover when it rotates through an angle of 88 degrees? So remember, first you got to think, is it asking for the area of a sector or the length of an arc? Decide which one it is, write down the formula, and find your answer. This one will be due in class. A segment of a circle. Now we've talked about segments in a linear sense between 2 points. Well, we also have a segment of a circle, and it's the region bounded by an arc and its chord. So look in this picture here, this green area is this segment of this circle. It came from finding the area of that sector, and we have to subtract out the triangle. So if I were to draw in the radii here, you can see this is where that orange triangle is over here. So for any segment of a circle, you just take the area of the sector and subtract out the area of a triangle. Let's take a look. Here we have circle N with a radius of 9, and we have the measure of arc LM is 120 degrees, which should tell you the measure of angle LNM is also 120 degrees. So we need to find the area of this shaded segment here, LNM. Remember, we need to find the sector area and subtract out the area of the triangle. Let's take a look at the sector area first. Remember, it's the area of the circle times the fraction that we are using. The radius is 9 centimeters, and the measure of the angle is 120 degrees. Now I'm going to go ahead and reduce this. 120 over 360 is a third of the circle. That makes it for easier numbers to work with. Now when I multiply 81 times 1/3, I get 27 pi centimeters squared for the sector area. I now need to find the area of the triangle. Remember, area of a triangle is base times height divided by 2. Well, over here in our triangle, we don't know the base or the height of the triangle. But if I were to pull that triangle out, I know this is 9 and this is 9 because both NM and NL are a radius of the circle, so they're congruent. I also know that this angle here is 120 degrees. So if I were to drop in my height, it bisects the angle so it's 60 and 60, which then creates a special right triangle of 30, 60, 90. Now I can come over here, change my color to remember that across from the 30 is x, across from the 60 is x squared root of 3, and across from the 90 is 2x. So when we divide both sides by 2, we get that x equals 4.5. So now I know the height of my triangle is 4.5, and the length of half of the base is 4.5 square root of 3, which means this is also 4.5 square root of 3. So the whole length would be 9 square root of 3. We now have enough information to find the area of our triangle. So I come over here, my base was 9 square root of 3, and my height is 4.5. When I multiply my numbers, I get that the area of the triangle is 20.25 square root of 3 centimeters squared. Remember, we have kept everything exact all the way until this very end. So my final answer is the sector area of 27 pi minus the area of the triangle of 20.25 square root of 3 centimeters squared. That is the exact area of the segment of the circle. If you needed the approximate, again, all you'd have to do is to type in the calculator and get your decimal approximation. But remember to organize your thoughts so you don't miss any steps. This last example here, you're going to find the area of segment RST. Remember to organize your thoughts, to organize your work as well, and box in your final answer. Give an exact answer, keep everything exact as you go. If you have any questions, please come in and see me, but this question will also be due in class. Good luck!